present String, layer 1 blockchain built from scratch. Our real goal is for user experience, and we've built and designed the whole blockchain for user experience. So I'm going to show you a couple features that are not seen in a layer 1 blockchain to this point. Okay, so just to start, there's a huge lack of programmability in blockchains. The problem is everything comes down to protocols, and they've built protocols that can transfer, create tokens, they can create NFTs, they can create a token in NFT, 1155, but they haven't actually made it so that developers can do anything beyond this. Smart contracts are even limited because they're done synchronously. Other thing is you have no privacy. If I'm an everyday user, someone's going to be taking my information, my transactional competency at all times. So what happens is they can do this with MEV, just like wall chain that we saw. It's also a cumbersome user experience. Across all generations, what we're seeing is that maybe 10% are using blockchain wallets. Yeah, they're maybe using exchanges, but they're not really using the products yet. So really, String brings user-controlled privacy to every data element in the system. Specifically, we also simplify authentication. We also create a powerful data layer that we call the String database that can support any object or any SQL database object model. And then we have Solidity integration. So we're similar to Sui having the objects, we're using Solidity to create these object models, which is a big benefit for Solidity developers. So what I'm going to demo is native account abstraction and encryption with data access controls. We're probably not going to have time for this last little demo. So here on the right side is the consensus on 11 nodes. Here at the bottom is a query for balances. So right now it's failing. So what we have is a PIN code and a password for your session. This is all using broadcast, and it's all encrypted inside of String across its nodes. So now we've opened a wallet with a simple PIN code and a passcode, and now you've got a session that's created, which is really simple, and you can use this for so many different use cases, which I'm about to point to here. So now I'm going to look at my query, and everything is done in parallel for transactions as well, similar to Aptos. So now you can see the balance is 1,000 ST3. The biggest thing here is that we can do decentralized SSO, so logging into String with any Web 2 application, any Web 3 application, you can just log in with a single click of the button. That makes it simple for all users. When you're doing something intensive, that's risky, we'll protect you by saying, okay, this transaction is above this, please use your private key. So here's another demo of permissions. So right now I'm querying Wallet 2's balance. What's happening here is that you're not getting any results. So now I'm opening up a second wallet, and now I'm granting 001 the read access to my balance. Now I can actually go in, query the balance, and see someone's balance, only with the permission of the user. On a public blockchain, this is really unheard of. So there's a lot of use cases that just change the game along with the data persistence. So now you're seeing no access because you can't write access to the balance. So this person's giving permission to write to the balance. Just like Vitalik receives so many Dogecoins unwillingly, you can control who sends you money as well on-chain. We're also layer 0 interoperable. String, because it's encrypted end-to-end, can inherit private keys and directly message Ethereum, Solana, Polkadot, and Binance, which is a great feature for this interoperability and containing all your data within the String network. We're going to skip over the media and assets persistence, but I would love to show the scalability of that system itself. When you look at the competitors in the market today, on-chain objects, Sui's coming in with that, but we have the privacy with on-chain objects, no MEV, BEV, Solidity integration, end-to-end encrypted, with event-driven programming like subscriptions. We're also partnered with Newcastle University, thanks to my co-founder, Mazen Youssef, and this is on supply chain and the University of Michigan to further investigate how we can protect our network level, because we want to constantly be evolving at all moments in time to improve our security. We also have secured a revenue deal very early on with Flide, which is working directly with Samsara for gateway devices. So these gateways, we're importing the data from the gateway devices, which aggregate IoT devices, and that goes directly into string associated with the wallet, which is the first time that you can do this at scale. So really our revenue is from transactions, our database, and the enterprise level. Our community traction, we have 7 development partners, 200K, we just started a few months ago, 200K Twitter followers, 3 investment growths, and thank you here. So.
Thank you. String 3.
Yeah.
Judges, while you're gazing through the team members?
Yeah, actually, my question was on the team, so great that. So, do you want to be like a layer 0 in between all the chains, and your main USP is the privacy and the read and write function, or is it something else?
Privacy is for any object on the chain, so everything's broken down into objects. So any chain that needs privacy can come to our network and use it. That's why we want to stay highly interoperable, and we don't want to directly come out and compete and say that we're trying to face them. But we scale parallelly. Our consensus is based on state changes, and it occurs in parallel as well. So we're directly competing. We're not really competing against the market. We're trying to give all these features that those chains wouldn't have.
And which sectors do you think need privacy today in blockchain?
So I think DeFi really needs the privacy layer, and you need scalability there. And I also think with payments and stable coins and anything regulatory in the government with data, you're going to have object sharing models that secure the data and allow you to work with those use cases.
Money laundering is a good use case, I guess. Sorry. Are you concerned about, regulation, money laundering, KYC, AML, all that fun stuff?
Yeah, so String is built for decentralized regulation. You can directly permission a set of transactions to a government agency, and they can view those transactions, but no one else in the network can view it. So we beat what zero knowledge is doing with zero trust by protecting the network level.